All right, I want to make an example of a question from section 8.2. And so I kind of stole parts of it. It doesn't necessarily copy and paste super well here. So you're conducting a multinomial hypothesis test with alpha equals 0.05 for the claim that the four categories occur with the following frequencies. So there's a couple things we just grab out of this here. We have alpha 0.05, and then our number of categories here, n, is 4. And that really helps us with our degrees of freedom that we'll need later, which is 1 less than our category, so that's 4 minus 1, or 3. So we have some expected frequencies here, some probabilities here, but we need expected frequencies. So I'll make a list, probability A here, just adding kind of a column to the front here, and then B, filling those in, 0.3 and 0.1. Now this should be a probability distribution, so these need to add to 1 to make sure we did it correctly. And we need to, from this, generate expected frequencies. So we're really interested here in the total of the frequencies. So I can use the sum function in Excel to add these guys up. Now that gets us 117. And so what it means, what we would expect to see is our probability here times, and I'm going to type in 117. If you click on the cell, you can get some funny things that happens. If I type in 117, I can just double click here, and then I get my expected frequencies filled out. Now, we need to submit our squared residuals, Pearson squared residuals. So I'm going to break that into a couple of steps here for this answer, and maybe I guess I can do the steps over here, and then maybe add them back. So here, let me bring those back. Maybe. Don't know if I can. Okay, so what we want first is we need to do the observed minus the expected. This is from our notes here. We have this. So here, what we observe minus what we expect. And again, if I go here, double click, fills them all out. Now the next thing is the observed minus expected values, and we square those. So I like to break it down into these steps. You can do it in one fell swoop if you want. It just kind of increases chances for errors there. And then lastly here we have the observed minus the expected quantity squared, and we divide by what we expected to see. So here, observed minus expected quantity squared divided by what we expected to see. And then this right here is the Pearson, the squared residuals. The sum of those is our test statistic. This is our chi-squared test statistic. So take the sum of these. Here's our chi-squared test statistic. So again, we got the sum here. For these, we just got these residuals. Give it a second here for the formulas so that you can kind of see those. As we go, we square, we do the difference. Letting Excel do all the work is a really good thing here. So then we're interested in the p-value. And these are chi-squared distributions that for the most part, they're just right-tailed. So we'll do chi-squared distribution right-tail, click on our test statistic, and then our degrees of freedom, which is 1 less than our categories here, so 4 minus 1 for 3. And again, that gets us our p-value. So here's this. If you want to copy and paste in here, this is the sum. And I've kind of added the work along the top there. Now we make a comparison of our p-value to alpha to make our decision. Same as we've been doing all along. So our decision here is the p-value is greater than alpha, so we reject if it's less, so we fail to reject or do not reject the null hypothesis. So, and then we would have an interpretation if we had a context for all of that, but I think this is most of what we needed to do for this question. So I hope that helps bring some clarity here. Again, this is just one of the questions from section 8.2, and I just wanted to work out some of it here for you to see. Thanks for watching.